Hey everyone, welcome to another lecture of this JWT Authentication System, and in this lecture we are actually going to start our hands-on coding. Alright, so in this lecture we are going to number one set up this project onto our local machine. Number two, we are going to create a GitHub repo for it where we will have all the code base in there. And number three, we are going to create a dummy server, right? So we are going to create a simple endpoint which will let us know that the server is actually working. So yeah, let's get started, guys. So at first I want you guys to come on your GitHub profile. So this is my profile, and you just click on this plus and just create a new repository. Then just give this project a name. So for here I will give this name. Next, you can choose any sort of visibility, so you can put it public or private. I'm going to put it as public over here, and then I'm going to create it. So with that, you can see that I have created a GitHub repo for it. Alright, now just go to your desktop or your downloads or whatever and create a new folder for this project. So I am going to come over here, and you can see that this is the folder that I have wherein I want all my code base, right? So I will just open this folder into my Goland. Now what is Goland? So basically Goland is a Go IDE by JetBrains. So here you can also use VS Code, but I will use Goland over here. So let me open it first. So as you can see, this is the project that I have opened in my Goland. Alright, now yeah, let's get started. So I am going to create two terminals over here, and I'm going to split it. And on my left I will name it as my simple Go session, and I will rename this right session as my simple Git session. So whatever GitHub commands that I will have, I will run over here, and whatever Go based commands that I will have, I will run over here. Alright, so let's get started. So at first I am going to create a simple readme over here. So let me create a new file. Yeah, so it's readme.md, and this is a basic readme. So this is the readme that I have created. Now let's initialize git into it. So basically enter this git init command, which will initialize a local repo for this. And then I want to create a .gitignore, and in that .gitignore I will basically ignore this .env file and a temp folder and a .idea folder. Alright, now let's follow these steps. So we have done this command, then we have to add all the files, and then we have to just do all these things. So I will just add all these files, and then I will put it a simple commit. So and I will name it as a first commit. Then I will just copy this command, which will add this origin, and then I will just push this, and I will set up the upstream with my main branch. And with that, my GitHub repo will be up and running. So as you can see, I have all my code base over here with this. This is a basic readme written into my readme. Alright, now I will just do two commands, which is this git branch and git status. So you see, I am currently in my main branch. Now first let's set this project up. Alright, so for that I will create a new branch. So I will check out a new branch, and I will name it as feed/project setup. Alright, so as you can see, I am in my feed/project setup branch, and yeah, let's get started. So the folder structure that I am going to follow over here is something like this, where we will have a internal folder at first, and inside this internal folder we will have every layer. So if you remember, we have all these layers which I discussed in MVC, and where is it? Not this one, yeah, this one. So we will have our routers, our validations, our controllers, services, repositories, and database related migrations and models. So everything will be created inside this internal folder. Alright, so let me just go and create them. So see, I have all these folders. So I have a config folder, I have a controllers folder, I have a database folders inside which I have this migrations folder and this models folder. Then I have this DTOs folder, I have this middlewares, repositories, routers, services, utilities. And where will I have the validations? I will basically have them inside my DTO layer. Alright, so in Node.js, you had to create this DTOs folder and your validations folder separately, but in Golang, we can create them into just one single folder and then we can use JSON tags for that. Alright, so this is the folder structure that I typically want, and then I will create another folder which will, help in running this app. So that will be inside my cmd/app. Sorry, that is cmd/app. Yeah, this one. And inside this, I will have my main.go, right, which will run this application. And this is the cmd folder. This is my internal folder. And then I will have a main.go, which will be the main entry point of this entire application. So this is my main.go, and inside this cmd/app/main.go, here I will put the package name as app because this belongs to my app folder. That is why I will name it here as the package as app. So this is it. And then I am going to integrate two more things, which is number one, I want to integrate this air, which will be used for live reloading our applications. And number two, I will create a task file using which, if you remember in Node.js, we have a package JSON in Node, which if you see, you will have this section, which is this script section. So yeah, this one, if you see, you have this script section using which you will define all the scripts, and then you will basically call npm run dev or npm run start, and that will run this script over here. But in Golang, we don't have this sort of support, right? So that is why we will use this task file, and then therein we will define all these commands. So that is why we will use this task also. So let's integrate them. But before integrating, let me first push them. So let me see what is the git status. So you see, it is just taking into account this cmd/app/main.go and these files, and not them because these folders are primarily empty. So instead of pushing, what I will do now is I will write a basic dummy server endpoint. Alright, so let's get started. Now first let's set up this config folder. So if you see inside my internal, I have created this config folder. Now why is that? So basically what will happen is that I will have a .env file wherein I will have all my server config. So I will have all my server config and I will have all my db config, and whatever details that I put over here, I will basically pull the config of this app from this .env. So for that I have this config layer, and inside this config layer I will have some files which are number one, an env config file, which will be basically helpful for loading these environment variables from this .env file. Then I am going to have a server config.go, which will be helpful for loading the config of this server instance. So I will have this server config. Then I will have the db config layer, which will have all the config related information for my database. And then I will have a logger config. So if you remember in the previous video, I talked that we are going to use a Zap Logger over here. So you see, a Zap is a logging package provided by Uber. So we are going to use over here. So that is why I will also create this logger_config, which will have all the config related information for my loggers. Now what will be there inside my env config? So inside my env config, I will write a small function which will be helpful for loading all the environment variables from this .env. So let's start writing it. So this env-config belongs to my config package. So that is why I have this package as config. So I am going to create this simple load single env variable function, which will be helpful for loading my environment variables, right? And this is going to be a generic function because in my .env I can have an environment like a port number. So I can have a port which can be something like 8080 or 9090 or let's say 3000, and at the same time I can have something known as a env, which can be a dev or prod or anything. So you see, this port is my integer and this env is my string, right? So that is why I want this function to be a generic function so that it accepts all type of data types. So that is why I am going to create it as a generic function, and this generic function, it will accept this t parameter, which will be a type of, it can be a type of string, or it can be a type of int, or it can be a type of float 32 or a boolean. And what it will accept is that, like, this is a generic function and it accepts this type of data types for my t, and it accepts two things. Number one, it accepts the key. So this key will be a string, and this key is nothing but this one. So this port, this env, so that is going to be my key. And I am also going to accept a default value, which will be a type of t. So whatever t I have over here, the same t type will be my default val variable, right? And I am going to return this t thing. So how it will actually work is that, let's say you want to load this environment variable. So what you will do is that you will just create this variable and you will call this function, and over here you will pass this key, which is this port, and the default value that you can pass here is as 3030, right? Or 3001. So this will be my default value and this will be the key, and it will primarily load this key from my this .env, right? So that is how we are going to utilize this function. And let's say that you want to load this environment variable, then what you will do is, similarly you will just copy paste this and you will call this an env, and then you will give it the key as this capital env, and you will pass a default string, which can be a dev or a prod or debug or anything, right? So that is how we are going to utilize this function. Now, how to load it? So for loading, we will basically do an os.lookup env, and wherein we will pass this key. And what it will return is, it will return two things. It will return a string and it will return a boolean. So this string is basically the value. So this is the value. So it will return this value, and it will return a boolean, which will basically tell if this key is present or not. So that is why I have named it as a exists variable. Alright, so I have my val and I have my exists boolean, and what this val will be, it will be a string data type, and this exists will be a boolean data type. So I will basically check if this environment or if this key does even exist in my env file. So if it does not exist, then I will just simply return my default val. But if it does exist, then I will run a simple switch statement wherein I will convert my this default val into an interface. So this any function, it will convert it into this interface, and then I will basically check its type by this. Now we have run a switch statement on the type of this default val, and then we have to write individual cases for these data types, right? So at first, if it is a string data type, then what I am actually going to do is that I will first convert my this val into an interface by doing this. So you see, it will convert my val into this interface, and then I will typecast it to my t data type. So whatever t data type that I have, I will typecast it to that. Next, if it is an integer, so if my val is an integer, then what I will do is that I will first convert this val into an integer. And how I will do? There is a function known as this strconvert.a to I, which will accept this string data type, and it will return my integer and an error. So I will basically accept them. Now, if this error is not null, that means that there was a potential error while we were parsing it. Then what I will do is that I will basically print it out, and I will tell that something went wrong while parsing this environment variable. And then I will also, log this error out by doing error.error. And if there is an error, then I will simply return this default value of that whatever I had, I will just return it out. And if there is not any error, then I will again convert this I to my any, which will make it an interface type, and then I will typecast it to my T type. So that is this idea of my int case. And then I am going to have another case for my float32, wherein I will again use this strconvert.parseFloat function. So this parseFloat function, if you see, it will take my string, which is my val variable, and it will take the bit size, which I want as 32-bit. And again, it will return two things. It will return this float variable and this error. So I will again do the same thing by doing this. And if my error is not equals null, then again there was some error while parsing this environment variable, and then I will return the default variable. But if there is not any error, then what I will do is I will first make this f variable an interface. But before doing that, I actually want this thing to be a float32. So I will convert this f variable. So if you see this parse float, it will return a float 64. So this f is my float 64, but I want it as my float 32. So I will first, typecast to my float 32. Then I will pass this to my any function, which will make it an interface. And then, I will typecast it to my T type. So that is the case for my float. And at last I will have a boolean type, and the code will be the same as my int, but there will be some changes. So here I will use my parse bool function, which will accept this value, and it will return two things, my boolean and my error. So I will name it as my b variable, and if my error is null, then something went wrong while parsing this environment variable, and then I will return this default val. And if everything is good, I will again convert this boolean variable into my interface type, and then I will typecast it to my T type, right? So they are all the cases for the switch statement. And at last I will have a default statement also, which will basically tell that if none of these cases matches, then I will do two things. I will first print a statement out by telling that an unsupported data type has been passed. So for this particular env, and then I will also put the name out, which is my key, and then I will return this default val. So this is the function that we are going to use throughout our application, using which we will be able to load environment variables from this .env file. So I hope this point is pretty much clear. Now we will have a server config and a db config and also a logger config, right? But before coding them out, let's create a simple dummy server, right? So for that, what I will do is I will just search this Chi router, and here if you see their code base or their GitHub repo, they will have this simple function. So I will just copy it out and I will run it inside my this main entry point, which is this one. So I will name it as my main function, and then I will write this code. So for using that, you need to install a couple of things, which is number one, you have to get this Chi router package. So just copy it and just come to your terminal and just paste it. So you see we got a error which is saying that go.mod not found, right? So like what happened is that to use any packages, you have to create a go mod file which will, initialize this as a package. So for that, let's see what is the command for it. So go init mod, and you will see that we have this go mod init command which will help our project to be declared as a go package, right? So that we can use everything. So we can run these commands and we can use anything. So for it will be go mod init. Then you will basically give a name, right? So go mod init, then you will give a name. And a good suggestion is that whatever name that you have over here, like this entire string, you just copy it out and that you paste it over here, right? So if you see, a go.mod file has been created by this. So github.com/ayushweb/yt JWT Golang, right? Now we can run this command which will install this chi router. So with that done, you see back to my main.go, this chi router and this chi middleware will be automatically be imported, right? Now how to run this main.go file is you basically do go run main.go, and that will basically run our server on this 3000 port. So you see this is working fine. So it managed to start my server on this 3000. So if you go to your localhost 3000, you will be able to see that this welcome is being printed, which is coming from this over here. So you see we have created this simple endpoint using this chi router. Now let's see how we can optimize this by creating this separate config layer. So we created this server config and we created this logger and we created this DB config. So let's see how we can utilize them to improvise this entire app building process. Now, before coding this server config and this logger config, I want to show you how a typical env for this project will look like. So if I go to my .env file, I will have two things. Number one, I will have my server config and I will have my DB config. So inside my server config, these are some of the things that I am going to have. So at first I will have this address or this ADDR, or basically it can be a port also, whose value will be :3000. So why :3000? So if you see in my main.go, this is how we are running this, right? So http.listen and serve, and then this is our address. So over here we are running it. So that is why I've created this port where I am storing this as a single variable. Alright, and next I am going to have a app environment which will tell me about the environment, and that will be my development. Alright, next I will have three more things, which are the read timeout, the write timeout, and idle timeout. So what are these? I am going to talk about it a bit later when we delve into a bit more into this HTTP module. But for now, keep that in mind that we will have these things. And then for now, I believe that is it. So let's go to our server config now. So this was our env config file. Now in my server config, I have to load these variables, right, which falls under my server config. So how we can do that? I will simply create a struct for my server config, which will be server config struct, and inside it there will be some properties which are first this port, this app environment, this read timeout, write timeout, and idle timeout. All right, so how it is going to look? We are going to have this port, which is going to be a type of string, and here I also want to apply some validation JSON tags where I will just tell that the validate of required, right? So this will basically tell that this port is a required field. All right, next I will have this read timeout, this write timeout, and this idle timeout, right? And I will make them a time.duration thing. So how it will work is I will have my read timeout which will be a type of type dot duration, and this type model, it comes inbuilt in Golang, and again it is a required field. All right, similarly I have a write timeout and I have a idle timeout. All right, I have this write timeout and I have this idle timeout. Good. And at last I will have this app env, which will be a string again, so it will look something like app env, which will be again a string, and again it is required. All right, so this is my server config struct for now. Now I am going to create a function which will load this server config using this function, right? So I will create a new function by the name of load server config, which will take nothing as parameters, but it will return two things. First is a pointer to my server config struct, and it will return my error. All right, now at first we have to load the env file. And how to do that? So if you search in Google how to load env file in Go, you will see that you need this package, right, which is a zoho/go.env. So you have to install this as a library. So just copy this command and come to your terminal and just paste it over here. And once that is done, you just load it. So how will you load it? Just type go.env.load. All right, and that will by default take your .env as your environment file, and it is returning one thing, which is this error. Just store your error, and you have to check if this error is not null. So if it is not null, it means that there is a potential error. So at that time what you will do is you will just print this error and you will just return out from this function. And how will you do that? So if empty.println, and like something went wrong while loading the env variables, and you just print out this error by doing that, and you will return nil as your server config and this error as it is. And once that is done, you will load your env and you will create your config, right? So here you load the env variables and you will create the config. And how do you do that? So you will just tell server config equals to I want it as a pointer, so that is why I did it as an ampersand of server config, and then inside it you have to define all of these things, right? So how will it come? Wait a second, let me just do it again. So it is server config. Yeah, so how this port will come? So for doing this, we are going to use this function that we created. So what we are going to do is that port is nothing but it will come from this function, which is load single env variable, and inside this the key is this port, and the default value is here, it is 3000. So let me have the same one, or let me have a bit different, which is 3001. Next we want this read timeout, write timeout, idle timeout, but please note that they're of type time.duration. So you have to convert them into a time.duration, and whatever these values are, they are basically, I want them to be in seconds. So for doing that, what you can do is you can just type out your load single env variable, and you want to load this variable read timeout, and its default value can be, let's say, 15. So this will give you this one. You will get this 10 as an integer, right? But here you defined it as a time.duration, right? So you have to convert it into your time.duration, and for doing that, you'll just call this time.duration function, and you will just pass this, and because you want to be in seconds, you will just multiply it by time.second. All right, so I hope this is pretty much clear, and the same thing I will do for my write timeout and my ideal timeout, but I will just change their name. So it is the write timeout and this idle timeout. And what will be the write timeout? Let's say I want it to be the same as this read timeout, but the idle timeout here it is 120. So here let's have something like 150, right? So this is something that we have completely in our control. And lastly, we have this app env, which will again come from our load single env variable for function. And this is my key. And the default value is, let's say that we will have development as usual. All right. So this is the config that I have created. And at last we have to return this config and then this nil as my error, right? So this is the simple load server config function, which will help to load environment variables from our .env file using this load single env variable, and it will be able to generate an instance of this particular struct, right? So I hope the idea is pretty much clear to you guys and how this server config is actually working. Alright, so what is this read timeout, write timeout and idle timeout? So basically your read timeout is the time allowed for reading the entire request, which includes your header and body. So basically this read timeout is the duration between your connection being accepted and the entire request body being read. So let's say that your client is uploading a very large or a very slow body, then it must finish within this time limit. And if that exceeds, then server is basically going to abort this connection, right? So this is the read timeout. So you are basically putting a limit on the time the server will take to read the complete request coming from the client. So this is the read timeout. Now this write timeout is basically the time allowed to write the response, right? So starting from the instance when your request headers has been finished being read, it is the time that the server needs to write the response out to the client. So let's say that your controller or your handler is very slow, or you make very slow DB queries and you have very slow downstream call, then this will be the limit. So if it exceeds more than this 10 seconds, then that connection will basically get aborted. So it not only limits your controller logic, but it also includes the network write time to the client. So if the client has a bit slow network and it is reading the response slowly, then if this exceeds more than this 10 seconds, then the connection will basically get aborted. So this is the write timeout. And what is this idle timeout? So this idle timeout is used for keep alive connections, where it tells how long the server keeps a connection open waiting for the next request after finishing a previous one. So let's say that your server has just completed a request, then how much time or for how much duration should that connection be open waiting for the next request? So if your idle timeout is 30 seconds, then after 30 seconds of inactivity, this particular connection will get closed. So this is the idle timeout. So I hope that these three concepts are pretty much clear to you guys. So yeah, that's it. And that is basically our server config. And next, let's see how to use this Zap, right? So I told earlier that we are going to use Zap loggers. So for that, we have this another layer, which is this logger config, right? So here, what I will do is I need to first install this logger package, right? Which is this Zap. So just copy this command, come to your terminal and just paste it out. And once that is done, I am going to create a new function by the name of get logger, which will take this variable. And what is this? This is my app env. So I will accept this app env, which is a string, and I will return a pointer to my Zap logger. So I don't think that it has been installed. Yeah, it has been installed. And I will return here a pointer to my Zap logger. And inside it, what I will do is, so you see, this is how we can create a new Zap logger. So what I will do is I will just come here and I will just type zap.must. So what it will do, it is that it is a helper function that wraps a call to a function returning your Zap Logger and an error. So you can do something like zap.must and then zap.newProduction. So inside Zap, you have two things. You have a production environment and you have a development environment. So what we actually want to do is that at first we are going to create a production logger. So for doing that, just type zap.must and then zap.newProduction. So zap.newProduction, and it will return your logger. Alright. Now you will check that if this app environment is your development, then you will use a development logger. Right, so this is where your app env comes very handy. So if app env is development, you will use a development logger. If this app env is production, then you will use this production logger. So at first you created this production logger, then you will check if your app env is this development string. So if app env is your development string, then you will update this logger variable to be a development logger. And how to do that? So the same process, zap.must and then zap.newDevelopment. Right, so this is how you are going to create your logger, and at last you will just return this logger. So you just return this logger. Now before this, you want to have a defer function which will run at this end of the function and which will first, accept your logger. So it will accept this logger, which will be a pointer to your logger, and you are basically going to create this defer function and you are going to immediately call it. So this is your defer function and you call it by passing your logger instance, and inside this what you will do is you will sync this logger. So if you see here, you have to do something like this, defer logger.sync, which will basically flush the buffer out. So that is why I am creating this defer function which is accepting this Zap Logger instance, and it will just do logger.sync. So logger.sync, and it is going to return me an error. So I will just accept my error and I will check if this error is not null, which means that there is an error actually. And in that instance, what I will do is I will just print this. So something went wrong while syncing the Zap Logger, and I will print this error. Alright, so I hope this idea is pretty much clear. So they just did it in one single line by doing this defer logger.sync, but I created a function and inside it I did that thing, which is again has the right effect. So this is how we have created this logger config, which will help to use our Zap Logger. And previously before that, we created our server config and our env config, and we also saw a basic structure of this .env file. So I hope that this config layer is somewhat clear to you guys. So now I will just push everything over here. So I'll just do git status, and you can see that these are the changes have been made. Now I'll just push this. So I will just do git add dot. Then I will write a nice message saying that create server and a logger config. Then I will push this. Alright. So these are the basic git commands. Right. So you see, if I do git branch, I'm inside my project setup branch, and if I do status, we have nothing because we just pushed everything out. Now if you come to your GitHub repo, you are going to see that we have this feed project setup branch, and inside that we have a new commit made by this commit message, right? So that is basically it for this video. So as a summary, in this lecture we created a GitHub repo, we saw this folder structure, and then we created a go-mod package, and then we wrote this config layer where we wrote this env config file, we wrote this server config file, and we created this logger config file. And also we saw how to make a dummy server using this HTTP module, and which is running over here. You see this localhost 3000. So that's it for this lecture, guys. In the next lecture, we are going to set up this database and we are going to use MySQL for doing that, right? So we are going to write migration models and we are going to see how we can use that throughout our application. So yeah, guys, take a break, keep coding hard, and I will meet you in the next lecture.
Let me tell you about that DE. I'ma be your recruit and